This video is going to cover some common ways that we organize quantitative data. So whenever you're deciding if you're going to organize or how you're going to organize it, you need to decide, is it discrete or continuous? Are they countable classes, or are they continuous numbers that go on forever, or do you have a ton of data? So if you have a few, like relatively few, discrete data points, you can use the actual data as your classes, and the center is just at the whole number. At whole number. So if I were drawing a graph 8, 9, 10, I would go like this, and from here to here would represent 8. And your other information would show you that. If you have a lot of data, so many discrete things, or your data is continuous, you have to make your classes into intervals. So we're going to go over both of these so that we can I can show you the difference in how those two things are. So a histogram is like a bar graph, except the rectangles all touch, and each one represents an interval or a range. So it's going to represent more than one number on a histogram versus a bar graph if it's one number. Okay, so starting with discrete data, we can go through and make a frequency table and make a bar graph that way. Or we can make what's called a scatter plot or a histogram on our graphing calculator. So if we hit the stat button, which is right over here, stat, and then enter, if you have anything in L1, you're going to arrow up and clear it out or delete it. Don't delete. If you delete it on your calculator, it'll go away. Hit clear. And then we want to type all of this data in there, hitting enter in between. So 7, 5, 2, 6, 2, 6, 6. So what I would do is just pause the video if I take less time than you do. If not, then you're good to go. But just make sure you get all your data points in there and double check them. Oops. 2, 8. All right, and then I'm just going to go through and double check. Okay, so those are all in there. Now, so these two are how you're going to get your stuff in there. Now to make our plot, we're going to hit the second button, and then we're going to hit y equals, which is right above it. And you have to hit enter one more time if you have a regular calculator to get to this screen. Now you want to make sure that on is selected. If not, hit enter over it. Then arrow down to the type and choose the one that looks like a bar graph. And then your frequency needs to say 1 and your X list needs to say L1. If for whatever reason it doesn't, hit delete, and then you hit second 1 to get L1 in there. Now we're going to set the window. The window is going to have the lowest number. So if we look in our chart, the lowest number is 1. Then our max, our highest number is 11. And then we'll use a scale of 1 because there aren't that many. Then our Y, start with 0. The highest frequency, so if there were a bunch of those, if we did them out, it would be, I think it's like 12. So we'll say 12. And then let's do that scale by 1. So you're going to hit the window button and then type those numbers in. So 1, 11, 1, 0, 12, 1, and then hit graph. And it shows you your histogram right on there with the frequencies. If you click on the graph, it should tell you the frequency or the height, like your plot n equals 11. So that's the height of that number. So those are just things that you can see. You can play with the window. If we were to change the scale to 2, it's just going to combine two numbers. So there's lots of different things you can do, but typically the words on your notes are what we'll use. Now, each class is the width of that bar. So your lower class limit is the smallest value in the class. The upper class limit is going to be the largest value in the class. And for the one we just did, they were 1. So like the lowest would be 1 and the highest would be just before 2. So it's kind of only one value when it's discrete like this. And then your class width is the difference between consecutive, so in a row, lower limits. So that'll tell us how long each thing is. And then and classes do not overlap. So you can't have a number that fits in both. You have to change your classes so they cannot overlap. And then the last part of this is sometimes on the ends you might have what's called open-ended, and it just has no lower or upper limit. So if we're on the top end and something goes on forever, sometimes you'll see it say like 101 plus, just meaning this includes everything past that. So let's look at some continuous data. Now we could do something similar. Actually, we're going to do it after. So first, we have all this data. We have numbers in here that go from 8.28 to 19.43. There's a whole lot of decimals. That's a lot of figuring out. We don't want to do each number individually. So we're going to decide to do ranges. Now for this example, we're going to use 12 classes. So to find that, you take the largest number, 19.43, minus the smaller number, and divide that by 12. So if I type that in my calculator, 19.43 minus 8.28 divided by 12, I get 0.9. Now, rounding down is normally what you do, but sometimes in this case, up is better just to make it look prettier. So we're going to use 1 as our class width. So if the lowest number is 8.28, we're going to start a class of 8. And then we add 1 to get each class. So the next class would be 9, 10, 11, and 12, all the way until our chart's filled. And then we fill in the other end. So if our lower class limit here is 9, and these are 2 digits, the biggest number this one can be is 8.99. Anything over that's going to be 9 and go in the next one. So for that first class, the lower class limit is 8. The upper class limit is 8.99. And we're just going to fill that in for the rest of the chart. To 12.99. And then we go through and tally as we go. So 10.94 would be here, 10.53, 14.12, 12.26, 12.17. And you go through and do your tally marks. I'll do mine. Pause the video if you need longer than it takes me. All right, once you're done, then we just take our tallies to make our frequency. So that has 2, 2, 4, 1, 6, 13, 7, 3, 1, 0, 0, 1. If we count the number of boxes or add those all up, we get 40. So our relative frequency is that number divided by 40, which gives us 0.05. And then 4 divided by 40 is 0.1. 1 divided by 40 is 0.025. 6 divided by 40 is 0.125. Nope, 6 divided by 30 is 0.15. 13 divided by 40 is 0.325. 7 divided by 40 is 0.175. 3 divided by 40 is 0.075. 1 divided by 40 is 0.025. 0 divided by anything is 0, and we already did 1. So there are all our relative frequencies. Now we're going to draw a histogram. So I'm going to make a number line. And we start at 8, and we just go all the way up. Now this goes all the way to 1999. So we just want our graph to go to the next lower limit. So we would just go to 20. Then over here, if we do like 0.05, 0.1, 0.15, 0.2, 0.25, 0.3, 0.35. Then we'll just draw our bars. So the first two go to 0.05. So 8 to 9, 9 to 10. Then this one goes to 1. And 0.025 is like half that. 0.15 is the next line. 0.325 is going to go all the way up here. Then what 175 is like here. 075 is like here. 025, 00, and 025. So that would be an example of a histogram where each bar represents a whole class between 8 and 9, multiple values. We can also do this on the calculator. So first we enter our raw data. So I'm going to go back to this screen just so I can see it. We can enter this right on your calculator. So again, we hit stat, which is right here, enter, clear that list if we need to, and then type the numbers. So take as long as you need, pause the video if it takes you longer than it takes me. Always double check after because it's really easy to mistype, especially if you're going fast. Oops. I know these are a lot of numbers, but when you're taking a test or a quiz, you are more than welcome. You can do it by hand or you can do it on the calculator. And if you choose to do it on the calculator, you just have to show me the picture of the graph. You don't have to draw it out after. So it's one or the other. You don't have to do both. So I'm just going to double check these. All right, and then if I need to turn this on because I've turned it off, go ahead. Otherwise, we can just go straight to the window. Now, our lowest value, if we remember, the lower class limit of the first class is 8. So we're going to put an 8 for our X-min. And then we use the lower class limit following the last class. So if we had one more, that would be 20, like we did when we drew it out. And then the scale is our class width. So when we did the math, we chose 1 as our class width. And then our Y minimum stays 0. Our Y max would be something higher than the largest frequency. So if this is 13, 15 is probably a good number to use. And then whatever scale we want on that, and then hit graph. And there is our histogram that matches the picture we drew. All right. Another type of display is called a stem and leaf plot. So what happens is you split it like a T-chart. The digits on the left are the stems. The digits on the right are the leaves. And you can break the numbers wherever you want. You'll just leave a key, which I'll show you in a minute. The biggest thing to get full credit is you want to order the numbers least to greatest when you're done. All right, so let's do this first one right here. We have 2-digit numbers. So we're going to make a key that says like 1/0 tells us 10. So if we look, we have some single digit numbers where their tens digit would be 0. Then we have some digits where it's 1. Then we have some digits where it's 2. So we listed all of the stems. Don't skip any. That's a big thing. Let's say the next number on here was 45 or 40. We'd still want to put the 3 there, and we would just leave that blank on the leaves. Now we're going to write the numbers where they get. So the 16 means there's a 6 that comes after the 1. 15 has a 5 that comes after the 1. 14 has a 4 that comes after the 1. 21 has a 1. 22 has a 2. And then our single digits are 5 and 4. So that's the stem and leaf plot. But to make it correct, we want to rewrite it where we put those leaves from least to greatest. So 4, 5, 6, and 1, 2. And that would be our final stem and leaf plot. We do the same thing with decimals. Our key is just going to say like 10 is 1.0. So we're saying that this time that this is our stem. So we have stems of 1, 2, 3. Now let's do our leaves. 4 and 5. The 2 is 3, 2. Then with the 1 we have a 5 and a 4. Another 3. And now we'll put them in order from least to greatest. Some people can look at these and do it right in their head, least to greatest. Smaller data sometimes is easier. Doesn't matter if you do a general one first and then create the least to greatest. Just let me know which one is your actual answer. Some other things you might see is a split stem. That just adds more classes. If you have a lot of numbers, but they fall into like 3 classes, it might be easier to split them up and do like 0 to 4 and 5 to 9. If I were to do the same one, I'd have like 0, 0, 1, 1, 2, 2. And these would represent the numbers 0 to 4. This would be 5 to 9. This would be 10 to 14, 15 to 19, 20 to 24, 25 to 29. And then if I take those same stems, it would spread this data out a little more. So if you have a lot of data, like really long ones, sometimes it makes it easier to see. A dot plot is a number line where dots represent frequency. So if I had a number line like this, 0, 1, 2, 3, and I had a couple dots, that means in this data set, I have 2 zeros, a 1, 3 2s, and a 3. So it's just another way to show data. Once we have our number lines or our dot plots or our stem leaf plots or whatever we're using, we can describe the shape. So there's some shapes that you're going to see more often than others. Uniform is when you have about the same frequency for all data points. So if you had a bar graph, it would look something where all the bars are right about the same height. Bell-shaped, which we also call a normal curve, is symmetrical with with the highest in the middle. Highest in middle. So if we had a bar graph for these, it would look something like this, where it grows up and then back down, and it's about a mirror image. Now, we're talking about data, so nothing's perfect. You just have to go with what it's the closest to. Another one you're going to see is skewed, where there is a tail on one side or the other. And the side the tail's on is the side you use to describe it. So skewed left might look like this, where it gets smaller and smaller and smaller over here on the left. Skewed right would look something like this, where it gets smaller and smaller and smaller over here on the right. So those are some different things that go with your ways to do data, and let me know if you have any questions. That is to